Okay, so this video is taken from bonding structure and properties of matter topic, and we're going to focus on ionic bonding. Before we actually start looking at ionic bonding in particular, we need to have a secure foundation knowledge about the structure of the atom, how to calculate number of subatomic particles, electron configuration, and then we can start looking at how ions form and then the properties of ionic compounds. Some really important topic links, cross-topic links, so found in atomic structure in the periodic table, chemical changes with a particular emphasis on electrolysis, active transport in biology, and atomic structure in physics. When you're watching these videos, it's really important that you keep your own notes. Here's an example of some Cornell notes I wrote for ionic bonding. Really easy to do. So you have the main section where you write down your notes as you're going through. The left-hand column will have key questions that you can think of. And then when we've come to the end, you can summarize all key facts and knowledge at the bottom of the page. So first of all, looking at the structure of the atom. There's the model of an atom that you've seen before. So we have this central region called the nucleus, and inside the nucleus we have the neutrons and protons. And then around the outside, in these shells, we find the electrons. We need to be able to label the structure of the atom, but then also recall their relative mass and relative charges. So protons have a relative mass of 1 and a relative charge of +1. So we're going to remember positive protons. Neutrons also have a relative mass of 1, but a relative charge of 0, neutral. So neutral neutrons. Electrons are very, very, very small. They actually have a negligible mass, or 0, and their relative charge is -1. Now, for ionic bonding, it's really important we remember these relative charges. How do we calculate the number of these subatomic particles in an atom then? Well, we use the information from the periodic table. We know the periodic table is a list of all known elements, and when we look at the periodic table, let's take sodium for example, we have the name of the element, the chemical symbol, and then two numbers. It's these two numbers that people get confused with all the time. The top number, it represents the relative atomic mass, the mass of the atom, and we've just remembered that the two subatomic particles with mass are protons and neutrons. So that top number is essentially the protons and neutrons added together. The bottom number is referred to as the atomic number or proton number. Don't worry if you forget what these numbers represent. On your periodic table, there is a key in the middle and it will remind you. So how do we calculate protons, electrons, and neutrons then? Well, sodium atom has 11 protons. We know that because that's the proton number. Atoms have the same number of protons and electrons, so that number also tells us a sodium atom has 11 electrons. And to calculate the number of neutrons is a really simple subtraction. So the relative atomic mass, which is the protons and neutrons, minus the number of protons, which is 11, 23 take 11 is 12. Based on this knowledge, what charge do you think atoms have? And can you explain why you think this? Pause the video and write an answer down. So atoms have no charge. And this is because they have an equal number of positive protons and negative electrons. If we've got the same number of positive and negative charges, these cancel each other out to make 0. This is really, really important, again, when understanding ionic bonding. I'm not going to go into how to go about drawing electron configuration. That would be for a video for another time. But as long as we recognise and are in touch with what electron configuration looks like, we know that these dots, or sometimes represented as crosses, are representing electrons. We can have up to 2 electrons in the first shell, up to 8 electrons in the second shell, up to 8 electrons in the third shell. And even though it's not featured on this diagram, you could have up to 18 electrons in the fourth shell. You will only need to be able to do the first 20 elements in terms of electron configuration, so that's up to calcium. So now let's start focusing on in terms of ionic bonding then. So the other two types of bonding include metallic and covalent. Again, these will be featured in another video. So what are ions then? Well, ions are charged atoms. So we said earlier that atoms have no charge, which means we're going to have to do something to that atom to give them a charge, and this can be positive or negative. Can you have a think about how ions form? Pause the video and have a go. So, if an atom loses or gains electrons, it's going to become charged. If an atom loses electrons, it will become positively charged. And if the atom gains electrons, it will become negatively charged. This doesn't make sense, and a lot of people get confused here because logic is telling you that if you lose something, you will become negative. But if we remember from the earlier slide, electrons are negative and atoms have no charge. So if an atom loses negatives, it will overall become positive. Makes a little bit more sense when we say if an atom gains electrons, an atom is gaining negative charges, so it will become negative. Here's some examples of some ions. So how does it happen then? Well, let's take a sodium atom, for example. So this sodium atom is found in group 1, has 1 electron in its outer shell. The number of electrons will correspond to that group number. So the electron configuration is 281. The sodium atom has two choices. It can either lose 1 electron or gain 7 electrons. So it's easy for the sodium atom to lose 1 electron, and in doing so will become positively charged. Let's take another example. Let's have a look at an oxygen atom. Oxygen is in group 6, therefore has 6 electrons in its outer shell. Two choices: gain 2 electrons or lose 6 electrons. It's easy for the oxygen atom to gain 2 electrons, so forming an oxide ion, O2-. Please notice that in both examples, we write the symbol and then the ionic charge in the top right-hand corner. So it's Na plus, a single charge because only 1 electron has been lost. And in oxygen ions example, 2 electrons have been gained, so it's 2-. We put the size of the charge first and then the actual charge itself. We can use our knowledge of electron configuration to understand what charge each atom in each group will form. For groups 1, 2, 3, 5, 6, and 7. Group 4 don't form ions, and group 8, group 0, they don't form ions either. Group 0 have a full outer shell of electrons, so do not want to gain or lose electrons or share electrons for that matter. Ionic compounds, ionic bonding always takes place between metals and non-metals. That's how we spot ionic bonding, if we see a metal and a non-metal bonded together. So how do we do it then? Pose it more of an exam style question. If we had to describe and explain the ionic bonding in a molecule of sodium chloride. So the sodium atom has 1 electron in its outer shell. It's in group 1. The chlorine atom has 7 electrons in its outer shell because it's in group 7. Pause the video and describe how a sodium atom will react with a chlorine atom. Okay, let's go through the answer. So a sodium atom will lose 1 electron to become positively charged, an Na plus ion. The chlorine atom will gain 1 electron to become negatively charged, Cl minus. The electron from the outer shell of the sodium atom has actually transferred to the outer shell of the chlorine atom. So it's important that we do talk about atoms losing and gaining electrons, but we have the knowledge that these electrons don't just disappear or get gained from somewhere random. The electrons are actually being transferred between atoms. The two ions are now attracted to each other because of something called an electrostatic force of attraction. That's what an ionic bond actually is. We know that opposites attract. A positive is attracted to a negative. And it's this electrostatic force of attraction that's going to hold these ions in place. Please pay close attention to the points that I've underlined. These are the key points that the examiner is going to be looking for. We're stating whether it's going to be a loss or a gain, the number, and what's being lost or gained in terms of electrons. Also state the charge of the ion that's formed. Let's have another example, but bearing in mind in terms of this written example. Describe and explain how a magnesium atom reacts with an oxygen atom. Pause the video and have a go at this question. So again, going through, you'll notice that the answer is very, very similar. The only difference is in terms of the type of the atom and the number of electrons being lost and gained, and the charges formed. So a magnesium atom has 2 electrons in its outer shell, will lose 2 electrons to become positively charged, Mg2+. An oxygen atom will gain 2 electrons to become negatively charged, O2 minus. The electrons from the outer shell of the magnesium atom have transferred to the outer shell of the oxygen atom. The 2 ions are now attracted to each other because of an electrostatic force of attraction. This is called an ionic bond. Hopefully you can see the model answers remain pretty much the same. The only thing that changes is the type of atom, the number of electrons, and the size of the charges formed together. Here's a slightly different example, but again, have a go to see if you can describe and explain how a calcium atom and chlorine atoms can react together to form calcium chloride. The calcium atom loses 2 electrons to become a 2+ charge, and each chlorine atom will gain 1 electron to become negatively charged. Strong electrostatic forces of attraction will hold these ions together. This is an ionic bond. Here's an example of an exam style question. Pause the video and have a go. So potassium reacts with fluorine to produce the ionic compound potassium fluoride. Figure 7 shows the transfer of electrons during the reaction. Describe what happens when potassium reacts with fluorine to produce potassium fluoride. Write about electron transfer in your answer. So looking at the question, we can see that we've got the electron configuration, but only the outer shell featured, and then the ions drawn as well. The question is asking us to describe what is happening, and it's also given us a massive hint at the bottom because it's told us to write about electron transfer in the answer. You should be able to spot that this is definitely ionic bonding because it's a metal, potassium is a metal, and fluorine is a non-metal. And if we're bonding metals and non-metals, it must be ionic bonding. The potassium atom has 1 electron in its outer shell, so we'll lose 1 electron to become a positive ion. The fluorine atom has 7 electrons in its outer shell, so we'll gain 1 electron to form a negative ion. I do recommend that we still continue to talk about these ions then being attracted to each other through an electrostatic force of attraction. This is called an ionic bond. Explaining properties. Well, ionic compounds have what we call a giant lattice structure. You can see on the right hand side this featured. So because of the giant ionic lattice, there's lots and lots of ionic bonds, and these are very, very strong forces of attraction, electrostatic forces of attraction. The electrostatic forces of attraction are all around the ions, so a lot of energy is actually needed to overcome these strong electrostatic forces. Because of the high amount of energy needed to overcome these forces, the melting point is going to be high. And the final property that we talk about is, do ionic substances conduct electricity? And we need to be able to explain why or why not. Well, it all comes down to whether ions can move or not. Electricity is movement of charge. If the ions can move, electricity will conduct. So pause the video and have a go at explaining whether solid, molten, and dissolved ionic compounds will conduct electricity. Some other useful links to help you understand ionic bonding.